What's
All right, 14.4, solve trig equations. Now, every year I go back and forth on if I want to do a review of inverse trig or not here. But I'm not going to because people tend to get confused. When we're solving trig equations, we're not necessarily following the rules of inverse trig, which I know is going to kind of throw some of you off a little bit, but we'll talk about it as we get there. But I'm going to skip that part. However, in this stuff, we have extraneous solutions.
Oh, I love this word.
Which are solutions to the problem that are not actually true. Or like don't make a true statement. Always check the solutions back in the problem to ensure they actually work.
I'm sure if like someone wrote my notes, they'd be like, "Is this English?" Always check solutions back in problem.
That's why I stay down here in math and ignore English class.
Yeah.
I have to do the 9th grade English next week.
Yeah, she told us. She told us we could ask you about los mis or whatever.
What?
Les Mis.
Yeah.
Yeah. I keep saying los in Spanish.
Might need to watch that movie this weekend. I don't remember that book.
I'm gonna watch it.
I read most of it.
600 pages.
I think I'm gonna read like 100 out of 600.
Yeah.
All right, we add 2 in pi for sine and cosine. I'll tell you what we do for tangent in a minute. To include all possible solutions because there are infinitely many solutions. And the reason for that is because if I ask you to tell me, the sine of like pi over 3, well, if I go all the way around to 7 pi over 3, it would be the same thing, right? It just keeps going around every increment of 2 pi. So that's what this is. The n is how many times we're going around, and then it's adding the 2 pi. Because that's how long it takes for a solution to get repeated, okay? Like consistently. Obviously, we have, like sine values are like always positive on top. So like you have 2 times that it occurs, but we can't just add like that little chunk because it's not consistent every time. Now with tangent, they are done every 180 degrees or every pi, right? Because quadrants 1 and 3 match and 2 and 4 match. So for tangent, leave space. I'm going to write something there in a second. But for tangent, we add n pi instead. So instead of being 2 n pi, it's just n pi, which would be the equivalent of 180 degrees. We only have to go halfway around to repeat a solution. This stuff is called the general solutions to a problem. So you have to look, is it asking you to find the general solution or a specific solution? A specific solution, they're going to tell you it's on the interval like 0 to 2 pi or 0 to pi or whatever the case may be. And so we're finding all the values that occur in that region. If we're finding all possible values, then we're finding the general solution. So these first few problems, and probably all we're really going to get to today, we'll actually get to solving tomorrow. Say to verify that the given x value is a solution of the equation. Now, in most cases, that probably means it's going to work and you're just confirming that, but it doesn't have to, right? You may plug it in, you may find it doesn't work, and then you would just write it's not a solution. So number 4 says pi times the secant of x plus pi is equal to 0, and we're plugging in that x is equal to pi. So you're going to need your unit circle handy with this stuff. So we plug in pi for x, so I have pi times the secant of pi plus pi equals 0. So just like what we did with like our verifying in the last section, I'm not moving anything to the right initially. Okay, I'm going to solve everything out over here. I'm showing that the left side is equal to the right. So when we get to actually solving equations, it'll be a little different. But while I'm verifying, I'm showing that the left side is equal to the right side, which in this case is going to be 0. So pi times the secant of pi. Well, I need to know what the secant of pi is. So using our identities, right, we know that this would be pi times 1 over the cosine of pi. Well, what's the cosine of pi?
Goodness gracious, that one, x, -1.
So this would be negative pi plus pi equals 0, okay, because this part, do this. This becomes -1. So negative pi plus pi is 0, so we have 0 equals 0, so I've confirmed that that one works. So basically, I'm showing that this was a solution that worked, it wasn't extraneous.
Rewriting my notes because I wrote them.
8.
Did you just erase pen? That's a pencil. She's writing with a pen. That's pink.
All right, 3 cotangent to the 4th of x minus cotangent squared of x minus 24 equals 0. And they tell us that x is 7 pi over 6.
Oh my goodness.
You really are special.
All right, so first of all, I would plug everything in, and then we'll talk about how I would rewrite this to make my life easier as far as solving. So I'm going to have 3 times cotangent to the 4th of 7 pi over 6 minus cotangent squared of 7 pi over 6 minus 24 equals 0. Now, because my classes are getting all mixed up, I think we talked about this the other day, but cotangent squared of x is the same as cotangent of x all squared. So I'm going to find the cotangent of 7 pi over 6, and then for each respective thing, I'm going to raise it to the 4th or square it. Okay, so I'm going to treat this as 3 times. Now, cotangent's not on my unit circle, so I'm going to do it as 1 over the tangent of the value. So I'm going to do 1 over the tangent of 7 pi over 6, all raised to the 4th, minus 1 over the tangent of 7 pi over 6. I don't know why I did extra parentheses on that. All squared, and then minus 24. So now I'm going to go to my unit circle and say, what's the tangent of 7 pi over 6?
Square 3 over 3.
Yep, so this is going to be 3 times 1 over the square root of 3 over 3, all raised to the 4th, minus 1 over square root of 3 over 3, all squared, minus 24 equals 0. Now, I would go ahead at this point, since I'm dividing by a fraction, and I would keep change flip. So it would just be 3 over root 3. Normally at that point we would rationalize. I'm not going to do that because they're being raised to an even power. So that stuff I can tell is going to cancel. Okay, so I'd basically just be doing extra work. So I've got 3 times 3 over root 3 to the 4th minus 3 over root 3 squared minus 24 equals 0. So this 4 goes on both things. What's 3 to the 4th?
9.
81 over.
Yes.
And then the square root of 3 to the 4th would be what?
Oh my goodness. Square root of 8.
So that's 81 over 9. Just gonna reduce, right? Minus over here 3 squared. 9 over square root of 3 squared is 3. So now, to not have to rewrite this whole thing, 81 over 9 is 9. 9 over 3 is 3. So I've got 3 times 9 minus 3 minus 24. So this is 27 minus 3 minus 24. 0 equals 0. Now, one other thing is, if you remember, we talked about on our unit circle, when I'm looking at it, to find the cotangent values, I actually just swap these two tangent values. So if I'm looking for the cotangent of pi over 3, that's equal to root 3 over 3. The cotangent of pi over 6 is root 3. These flip when we're dealing with cotangent. So if you remember that, you can also do it that way, which would have shortcut this a little bit, but I felt like that's something we're not as inclined to remember, so that's why I wanted to show it this way. So we're going to pause there. We'll pick up solving tomorrow. It shouldn't take us too long. It's only like 5 or 6 examples, and then you'll have the time to work after that, aside from, obviously, your identities thing.